Hello friends, welcome to lecture number 15 of electricity and magnetism. Today our topic of discussion is conservative nature of electric field. Right. So I have given all the links of all the lectures in the description box. If you want to watch them, then you may go through. Okay. So before we start, please subscribe the channel if you are new to my channel. Also share with your friends, and if you think these videos are helpful, please share with your friends and hit the thumbs up button, and also hit the bell icon so that you get notified when new video will be uploaded. So now let's start. So now you see, when we say a field is conservative, so the line integral of electric field, so we are discussing about the conservative nature of electric field, right? If the line integral of electric field is independent of path, if we can show that line integral of electric field is independent of path, then we can prove that electric field is conservative. And also closed line integral of electric field is 0, right? So now let us suppose we have a charge q here, q, and we need to move a charge q naught test. This is a test charge, small charge q naught from this point A. The position vector of this point A is r1. Suppose, let me write the position vector of this is suppose r1. This is r1, right? And we are to move this charge along this path to B. So this is another point B. So its position vector B is suppose r2. Its position vector is r2. Suppose r2. And so we are to show the line integral of electric field. The electric field due to this q positive charge will be around will be radially outward, right? So it will be like this, right? So this will be the electric field due to this q charge, right? So now you see, and if you bring this charge back from the point B to A, then the total line integral along this closed curve, along this closed path, that will be equal to 0. Okay, now let me show that. Now here you see electric field. Now let us take a point P here with position vector r. Suppose this is the point P, this is the point P, and its position vector is suppose r vector, right? Its position vector is r vector. This is the r vector, and its direction is given by r cap, right? This is the direction of this position vector r cap. And now at this moment this q naught is here at point P, and we are to move along this direction through a very small distance, suppose dl. Let me, and its direction will be this is the direction of dl, right? So it is a very small distance dl. Suppose this is a very small distance dl and makes angle theta with r. Suppose, let us consider it makes angle theta with r, right? So now you see, so the electric field at this now work done to move q naught a very small distance dl is dw is equal to, and force acting on this charge q naught, that F dot dl, right? This dl vector. And now you see, suppose theta be the angle between r cap and dl vector. Let me consider that way. So what will be the work done to move? Before that, let me tell you one more thing. Let me go to the next slide. Let me copy this last expression. And as you know that if q naught the force acting on Q naught is suppose F, and then at this point R vector, the electric field at this point is given by the force per unit coulomb charge, right? Per unit coulomb charge by definition of electric field at this point. So here you see, we know that we have already got these things, this one, that by definition electric field, this is equal to limit Q tends to 0 F by Q naught. We have got this by definition, right, of electric field. So if Q naught, the test charge is suppose 1 coulomb, then we can say that F will be equal to E, right? Then we can write dW is equal to E dot dl, and for this whole part from A to B, let us find the work done, total work done, W from A to B, right? So that will be equal to A to B, right? A to B, position vector of A is R1, so let us write here R1, and here R2. The position vector of B is R2, so let me write here R2. So E dot dl, right? E dot dl. So now you see, let me write it properly. Okay, R2. So now you see electric field at this point P, here you can see, whose position vector is R vector. So at that point electric field is given by E is equal to 1 by 4, or you can write Q by 4 pi epsilon naught R square. So you can write this, or let me write it again, 1 by 4 pi epsilon naught into Q by R square, right? You can write that way, and in vector form, here R cap will be the direction of the electric field at this point, right? So we will get R1 R2 1 by 4 pi epsilon naught Q by R square R cap, right? So this is the line integral of electric field, and we have dot dl, right? Dot dl, this is what line integral of electric E dot dl, right? So now if you integrate this part is constant now. So if you integrate this, and one more thing, R cap dot dl, what will be that? So let me explain here, let me explain on the next slide. Okay, now you see, now let us consider this portion. Here you can see, so here is the suppose R cap, and this is the dl, this is the length dl, and this is the dl vector, right? So that means we are considering this portion. Consider this case, angle between these two is theta, suppose, and here is the perpendicular from this point on R, from this point on R, such that this length is suppose dr. So this is suppose dr. So now you see L dot dl, now dot product of R cap and dl vector, so that will be given by magnitude of R cap dl, magnitude of dl vector cos theta, right? So now you see R cap is a unit vector, so its magnitude will be 1. So we have got dl vector, we have got dl vector, magnitude of dl vector and cos theta, right? Dl cos theta. Now from this diagram, what will be dl cos theta, right? Here you see dl cos theta. If this is the right angle here, so this is going to be the hypotenuse and this is going to be the base. Then base by hypotenuse is cos theta. Here cos theta, base is dr and hypotenuse is dl here. So our dr will be equal to dl cos theta. We can consider that way. So that's why we can replace this by dr, right? So just let me draw it properly. This is the r vector and this is the l vector, and dl vector, and from here we have drawn a perpendicular to r cap, and this is the angle between them, theta, and this length is supposed dr. Then we can write r1 to r2 1 by 4 epsilon naught is constant, so it can be written outside. Q also can be written outside, so 1 by r square dr, we can write that way. And integrating that, what are we going to get? Q by 4 pi epsilon naught. So 1 by r square, if you integrate this, you're going to get 1 by minus r1 to r2, because integration of 1 by r square can be considered as r to the power minus 2. If you integrate r to the power minus 2 dr, then you will get r to the power minus 2 plus 1 by minus 2 plus 1, which is equal to minus 1 by r, right? So hope you know this integration, right? So now let me clean this. So here you see, then if you put the limits, then you will get 1 by 4 pi epsilon naught. So if you put r1, then 1 by r1, then minus 1 by, now let's put r2, right? So that's going to be equal to q by 4 pi epsilon naught r2 minus r1, right? So this sign going to be plus, minus, minus, plus, so positive term is written first. So this is the line integral from r1 to r2 of E dot dl, right? From this expression you can see this is the position vector of first point, this is the position vector of last point. That means it is independent of the path Now if you take the if you find a closed line integral, let me write this expression again. If you find the closed line integral, right, dl, so that means that will be given by line integral from, let me write here, this is r1, that should be r1 to r2, right? So on the previous slide also, here this should be r1, so let me write here, this is r1, right? So now you see integration from r1 to r2 E dot dl, then plus, then again from r2 to r1, right, E dot dl, that should be equal to 0. This closed line integral should be 0. That means line integral along this closed curve from a to b, again from b to a, this should be 0. Okay, so now here you see, so if from r1 to r2 the line integral of this E dot dl is this one, then what will be the expression for let me bring it down, just wait. So now then what will be line integral from r2 to r1 of E dot dl, that will be definitely q by 4 pi epsilon naught Here we have 1 by r2 minus 1 by r1, so that's going to be 1 by r1 minus 1 by r2, right? Now let us add these two. So this is equal to this one and this one is equal to this. So line closed integral, like closed line integral E dot dl, that's going to be equal to, now if you put the values here, you will get q by 4 pi epsilon naught. This part is taken common, q by 4 pi epsilon naught is taken common, suppose, then within bracket what you will get, 1 by r2 minus 1 by r1 plus 1 by r1 minus 1 by r2, that's what we're gonna get. So if you see this, these two cancels, then these two cancels. So what we have got? We have got q by 4 pi epsilon naught into 0, which is equal to 0. That means what we have got? We have got closed line integral E dot dl is equal to 0, which means electric field is conservative. So hope you have enjoyed this video, and if you have enjoyed this video, please share with your friends, hit the thumbs up button, and also hit the bell icon. And if you are new to my channel, please subscribe the channel, inspire me to create new content for you. Stay connected. See you in the next video. Thank you for watching.